What up, guys? Welcome to the lesson on completing the square for solving quadratic equations. So we start the lesson with a do now. It's just the first part is to write the standard form of a quadratic equation. So the standard form is, if we recall, is just ax squared plus bx plus c. Standard form. And then part B, it says given y is equal to 3x squared plus 6x minus 9, what is A, what is B, and what is C? So again, we're just kind of going back to our previous lessons. We have A is equal to 3, B is equal to 6, and C is equal to negative 9. That is it for the do now. So our objective for today, guys, is given an understanding of quadratics in standard form, students will complete the square to solve quadratics and change from standard form to vertex form. So, you guys, again, just to kind of remind you, you can pause the video at any time and just kind of play along. You can rewind to see examples over again and just kind of go at your own pace. This is just for you. With this said, I'm going to go ahead and fill in the blanks, exactly what it is we're going to do. So, students will, we're going to have complete the square and solve quadratic equations. So we're just going to solve quadratic equations. In what method? In completing the square method. So far we've taken care of two other methods. We've done factoring to solve and square root method. So let's take a look at this completing the square method. So we start off with a definition. So in your notes, you should copy this definition down in your vocab logs or in your index. Completing the square is the process of turning any trinomial into a perfect squared trinomial to solve with greater ease. Yeah. So again, it's the process of turning any trinomial into a perfect square trinomial to solve with greater ease. Just to kind of recall what a perfect square trinomial is, I again wrote the definitions down or an example of each. So if we're able to take the last term and if the last term is a perfect squared and we're able to take the square root of that, for example, the square root of 9 is 3, and multiply it by 2, we should be able to get this middle term or our b term. So if we have a squared plus 2ab plus b squared, then we can just factor this out fairly easy. So again, square root of the last term of c is 3, and multiply that by 2, we get 6. So this actually just factors out to be x plus 3 squared. And the example to my right, again, this time it just has the negative sign, so it's the exact same concept. What's the square root of 4? 2. 2 times 2 is 4, so that works out. So my perfect square, my factorization would be x minus 2 squared. And that's it. So we're going to use this kind of mentality when it comes to solving using the perfect or completing the square. So let's start with an example 0. So 2 lessons ago we solved by finding the square root. So again, I'm asking you to do the exact same thing. So let's go ahead and solve by finding the square root. So again, I would pause at this moment, write this example down, and then figure it out with me or kind of solve it with me. So I'm going to go ahead and add 25 to both sides. By doing so, I get rid of this term and I'm left, and I set this equation equal to 0. Remember, if we want to find roots, we got to set it equal to 0. So if I add this, I'm left with 9. At this point, this is known as a perfect square trinomial. So it's like our previous example. In fact, it's this one right here. And we can factor this out fairly easy, except for this negative sign. So if we want to factor this out, this just becomes x minus 3 squared is equal to 0. So now we take the square root of both sides. Square root of this part, square root of this part. What ends up happening, this squared term cancels out my square root, and on my right hand side I'm left with this plus or minus. It's just 0. So we really end up with x minus 3 is equal to 0. If I add 3 to both sides, this goes away. I get x is equal to 3. That would be your answer. So that would indeed be your root. Now let's take a different approach, just to kind of make a side note of things. So you guys might want to write this down. If I don't take the square root, I'm left with x minus 3 times the quantity of x minus 3 is equal to 0. At this point, this is the same as saying x minus 3, quantity of x minus 3 squared. What ends up happening is that we can apply our zero product property rule. And our zero product property rule guarantees us at least one solution. So we can set this up as x minus 3 equals 0 or x minus 3 equals 0. If we solve, we get x is equal to 3 and x is equal to 3. So it's true that our solution is x equals 3, but in this case, we get a double root. So we would write both roots down. And we'll discuss why that happens later on. So this is indeed a double root of x is equal to 3. So now we're going to go into our 5 steps for completing the square. 5 steps. So please copy these steps down. Have them in your notes as a reference point. And again, you can always look at the video to kind of see what you missed out on and then work from there. So let's go ahead and do step 1. Step 1 is to get the x's alone. So I'm going to get the x's alone. And then sometimes we need to factor a if we have one. So factor a if needed. If needed. Okay. 2. So step 2 would be to divide b. Divide our b value in half. Then square it. So we divide our b value in half and then square it. We're going to jump to step 3. We add to both sides. Add to both sides. Step 4 would be to factor. And at this point, we've already done our factoring method. And then step 5 is just to solve for x. Solve for x. Excuse me. So if we recap, step 1 is to get the x's alone, factor a if needed. Step 2, to divide b in half, then square it. Step 3 is to add to both sides. Step 4 is to factor, and step 5 is to solve for x. So I understand that right now this might not make a lot of sense, but given the next example, we can kind of piece it together and see how this works. So the next example, or actually example 2, we'll see how it works. Before we actually start solving with the completing the square, I want to do one basic example and see if we can actually turn this trinomial into a perfect square trinomial. By doing so, we want to find what our c value is. So in your notes, you should write example 1 and write this down, and you should have this quadratic written down. So we want to find out what c is. So if I have x squared plus 16x plus c, I want to find out what that c value is. So we're going to do a few of the steps from our actual, from the previous 5 steps. We're going to divide b, so my b value is 16. We're going to take my b value and divide it by 2. When I do so, I get 8. Then step 2 also tells me to square it. So I'm going to take 8, then square it. When I do so, I get 64. By doing this, I turn this regular trinomial into a perfect squared trinomial. So if I substitute my c value back into this equation, I should get x squared plus 16x plus 64. Now this becomes a perfect square trinomial. And again, if we go by our definition, if we we take the square root of 64, we get 8. Multiply that by 2, we get 16. This can be factored out very easily as x plus 8 squared. So this fits our definition of a perfect square trinomial. So this is a basic step. This is a basic example before actually starting to solve. So now that we kind of got that going, let's take a look at an example 2 where it just says straight out solve. Now when we want to solve for roots. So if it helps, go ahead and write solve and then write for roots. And again, our roots are called zeros, also x-intercepts, and our solutions. So let's go ahead, please write this example down as well. I'm going to write each one of the steps and then show you guys how it's done. Step 1. Step 1 says to get all my x's alone and factor a if needed. So what does it mean by getting my x's alone? I have an x squared here and an x there. Does this value have an x? It does not have an x. So which means we have to move it to the other side of my equal sign. And again, when we move, we're really just subtracting from both sides. So I'm going to go ahead and subtract 4. So I'm going to rewrite this equation just to be cleaner. And I'm going to subtract 4 from both sides. I'm sorry. Yeah, subtract 4. So minus 4, minus 4. This goes away because 4 minus 4 is 0, and we're left with x squared minus 12x is equal to a negative 4. We're left with this blank spot. Now this example is very similar to the one that we saw in example 1, meaning we want to find out what value will turn this trinomial into a perfect square trinomial. So we're going to go to step 2. Step 2 says to take my b value, well my b value is negative 12, divide it by 2, then square it. I'm going to do that in 3 lines. It's very, very important that you do this in 3 lines. So we're going to go negative 12 divided by 2 is equal to negative 6. Please don't do it in the same line, because what ends up happening is if you square it and you get 36, this math equation does not make sense. Negative 12 divided by 2 is not equal to 36. We added this squared term in between, so it does not make sense. So please write this in 3 different lines, just for proper math notation. You'll thank me later when we prove the quadratic formula. So I'm going to go ahead and take this negative 6, and I'm going to square it. When I square it, I get 36. So that's step 2. So now I'm going to go to step 3. I'm going to take this 36 and I'm going to add it to both sides. What does that mean? That means that in this equation, we left a blank space. I'm going to go ahead and add this 36 right in here. Well, if I add 36 to one side, I have to add it to the other side. So let's go ahead and rewrite just to show you those steps. I have x squared minus 12x plus my 36 that I'm adding is equal to negative 4 plus my 36 that I'm adding again. When I do this, I'm pretty much done with step 3. I'm going to go into step 4. Step 4 tells me to factor. Well, this becomes a perfect square trinomial, and it's easy to factor. Square root of 36 is 6. Multiply that by 2, I get 12. So this actually just factors to x minus 6 squared is equal to, and I simplify it on this side. So if I subtract 36, if I subtract 4 from 36, I get 32. And then this just becomes solving by the square root method. Meaning, for step 5, I have to solve for x. Step 5, if I want to get rid of the square root, if I want to get rid of the square term, I got to square root both sides. So what you do to one side, you have to do to the other side. Now this squared and this square root cancel out, and on my right hand side, please do not forget the plus or minus. So now we bring out whatever's left over. That's x minus 6 is equal to my plus or minus square root of 32. And if I'm solving for x, there's one more step I have to do, plus 6 to both sides. So this goes to 0. I'm left with x is equal to 6 plus or minus the square root of 32. And as tempting as this might look, as our final solution, it is not. Remember, if you can reduce a radical, go ahead and reduce it. This actually branches off or breaks up into into a factor of a perfect squared. So it gives me 6 plus or minus the square root of 16 times 2. Well, my product property rule tells me that I can break this up into the square root of 16 times the square root of 2. So one more, we get 6 plus or minus 4 times square root of 2. Now, just for right now, I do want you guys to write the answers as two separate roots. So let's go 6 minus the, whoops, getting ahead of myself. Let's go 6 minus 4 root 2 and 6 plus 4 root 2. This would be my solution to this quadratic function. I know, it's a lot of work, guys, but I mean, if you follow the steps, you're guaranteed to get the correct answer. You just kind of have to practice this a little bit. And later in class, we'll compare these roots to an actual graph and see how they kind of relate and kind of talk about it in class. So, again, you guys can go at your own pace. Please rewind this if you need to see this example again. But depending on your comfort level, I have chosen 3 different examples, and we knock these out in class. But for the sake of the video, I can show you real quick how to knock out 2 of these. I'm going to show you the yellow one, and then I'll show you the green one. So for the yellow one, I'll use blue ink. Let's go ahead and knock out all 3 steps. So step 1, we have x squared plus 6x plus 9 is equal to 36. So we're going to want to, again, leave our x's alone or get our x's alone. So I'm going to subtract 9 from both sides. Subtract 9. This goes away. X squared plus 6x is equal to 25. Well, step 2, I need to get my b by itself. So b is equal to 6. I divide that by 2. I get 3. Then I square it. I get 9. I'm going to go ahead and add that to both sides. So step 3. Step 3 then says to add to both sides, so I'm going to have x squared plus 6x plus my 9 is equal to 25 plus my 9. And remember, this 9 came from up here, from step 2. I'm going to go ahead and factor this out into step 4. This is a perfect square trinomial, so that's going to just be x plus 3 squared is equal to 36. Yeah. Wait. Make sure I did that right. That should be 34. Let me check my notes. Yeah. Cool. So, all right. So it's actually 34. So let's go ahead and write 34. Cool. Now we're going to do our square root method again. So I'm going to take the square roots of both sides. Just do to one side, you do to the other side. This goes away. We get a plus or minus on this side. So we end up with x plus 3 is equal to my plus or minus square root of 34. So I'm going to bring step 5 up here. Step 5 just tells us to solve. So I have x plus 3. So let me just kind of divide this out. Give us a little bit of workspace. X plus 3 is equal to plus or minus square root of 34. We get x, subtract 3 from both sides, is equal to negative 3 plus or minus the square root of 34. Now we try to break up 34 into a perfect squared, looking for a perfect square term. We're quick to notice that this 34 actually doesn't have any perfect squared numbers or factors. So the only factors that go into 34 would be 2 and 17. So that gives us 2 solutions. It's x is equal to negative 3 minus the square root of 34 and negative 3 plus square root of 34. That would be our yellow solution. So just to kind of do our green one really quick, let me make sure I can delete or erase all of this stuff. Actually, I'm going to go ahead and pause and then erase it and then start up again. Alright, just about done. Okay, so let's go ahead and knock out that green one, just so you can see an example of what to do when you have a leading coefficient. So my step 1, I have negative 5x squared plus 35x plus 40 is equal to 0. Alright, so first thing we're going to do again is my step 1. I'm going to subtract 40 to get my x's alone. This goes away. I get negative 5x squared plus 35x is equal to negative 40. Step 1 also says to divide by a, or factor an a if needed. So another word for factoring is really just kind of dividing. So if I want to factor out an a from all of these, I can actually pull that out or just divide all sides by a. In this case, I want to divide it by negative 5. I divide this by negative 5. I divide this by negative 5. When I do so, I end up with x squared, and then I end up with minus 7x is equal to 8. Yeah, 8. Just making sure. So step 2 says to locate my b. Well, my b value is negative 7. I'm going to divide that by half. I get, divide that by half. You can actually leave it as a fraction or turn it into decimal. I like fractions better, but for the sake of this one, let's go ahead and just kind of switch it into decimal and see how that works out. That goes into this 3 times. You get a 6. You don't have to put the negative, sorry. That gets a 6. Just ignore the negative. Actually, let me just kind of erase it out. There it is. When we subtract, we get a 1. We bring out the decimal. 10, that goes into a 5 times, so it's 3.5. So if I take my b value and square it now, I'm going to take 3.5, and I'm going to square that value. Well, 3.5 squared. Let me just grab my calculator real quick. Times 3.5 is 12.25. So it's 12.25. So then I'm going to jump to step 3. Well, step 3 says to add to both sides. So I'm going to have x squared minus 7x. I'm going to add my 12.25 is equal to, on the other side, I get 8 plus 12.25. So I'm kind of running out of space here, so I'll just stack it on top of each other, 12.25. When I do so, I'm going to go to step 4 where I factor this out. When I factor, I get x is equal to our b value, which was minus 3.5 squared. And when I add these two together, I end up with 0, 0. Let's get, alright, so I had a kind of a glitch with my computer, but it's all fixed, so we're good to go. So where we left off was step 4. So when we add these two together, we end up with 20.25. At this point, we do our square root method. So we begin to solve, which is our last step. This goes away. We get a plus or minus. We're left with x minus 3.5 is equal to, well, we can actually take the square root of that. The square root of that should be plus or minus 4.5, I believe. I'm just checking my notes. So we're going to go ahead now and add 3.5 to both sides. Add 3.5 to both sides. This goes away. We get x is equal to two numbers, 3.5 minus 4.5 and 3.5 plus 4.5. When we do so, we're left with two numbers, or two roots. Our very first root would be negative 1, and our second root should be 8. That's it, guys. So that's this is actually a very difficult example to kind of work out. So if you can follow through, then you're in good hands. You're in good steps. Let's go ahead and move on. Example 4 says use completing the square to rewrite vertex form. So our example 3 was our last example that we're going to show the 5 steps. But when we use completing the square method to rewrite in vertex form, earlier in the lesson I taught you guys how to do that a different method using the axis of symmetry and all that good stuff. Here I'm going to actually use the 5 steps. So I do want you guys to practice this. What I'm going to do then for step 1, since we're kind of used to writing this as a 0, you can do it 2 ways. You can either write this as a 0 and then just kind of change it back as a y. For this example, I'm going to just keep it as a y. So x squared minus 10x plus 22 is equal to y. So I just rewrote it the other way. I'm going to go ahead and my step 1 is to get my x's by itself. So I'm going to add 22 to both sides. When I do so, this goes away. Again, I'm left with x squared minus 10x. I like to leave a little bit of space to remind me that there's something missing there. And I get y plus 22. Step 2. My b value in this case is negative 10. I'm going to take negative 10 divided by 2. I get negative 5. I'm going to square that. I get 25. Step 3. I'm going to plug directly back into this one. What am I plugging in? I'm plugging in that 25. So I get x squared minus 10x plus 25, which you do to one side, you have to do to the other side. So plus 25 on this side. I go ahead and jump into step 4. Step 4 tells me to factor. So step 4, this factors out to x minus 5 squared. I'm going to simplify my right hand side. I get y is equal y plus 45. Plus 45. And then my final step is just to subtract from both sides. This is the only difference, this is my step 5. Since I'm not solving for roots because I have a y, I'm going to subtract from both sides. So if I subtract from both sides, this goes away and I get x minus 5 squared minus 45 is equal to y. And you can leave the y on this side or return it back to the left hand side. It's the same exact solution, but I know that we're more comfortable writing it this way. So there is our vertex form. If I want my vertex, I know that I can graph this thing at 5, negative 45. That is my vertex. So again, we can actually get this by using those 5 steps for completing the squares. So I have one final example to go over. This is a little harder one, so it's just green. And I'm going to teach you again what to do if you have a leading coefficient. So the first thing I always like to do is to rewrite this to a more comfortable form. Negative 16x squared plus 96x plus 3 is equal to y. I'm going to go ahead and subtract 3 from both sides. Minus 3, minus 3. This goes away. I get negative 16x squared plus 96x is equal to y minus 3. I'm going to go ahead and step 1 still. If I have a leading coefficient, I have to divide by negative 16, divide by negative 16, divide by negative 16, divide by negative 16. Every single term. We know that this goes away and this simplifies. So I'm going to rewrite that as x squared. I believe that goes into it 4 times. Let me just check my notes. Actually, it goes in it 6 times. Yeah. So it divides into it 6 times. We get negative 6x, and we get y over negative 16. And this actually reduces to a positive term, which is 3 over 16. Okay. So we're going to go to step 2. Step 2 is to take my b value, negative 6. I'm going to go ahead and divide that by 2. I get negative 3, and then I'm going to take negative 3 and square it. I get 9. So if I go to step 3, I'm going to just plug that 9 directly back in, and I get x squared minus 6x plus 9. And I get is equal to, since they have the same denominator, no, let's leave it like that. Okay, we get y over negative 16 plus 3 over 16 plus my 9 over 1. I'm going to factor this out for step 4. I get something nice like x minus 3 squared. And I'm going to combine my like terms on this side. So before I combine my like terms here, I have to multiply my denominator by 16. And what you do to the denominator, you do to the numerator. So what I am left with is y over negative 16. When I combine these, I get plus 3 over 16. 9 times 16, I wrote it down on my notes, is 147. Making sure that's correct. Let me actually do that on the calculator just to make sure, triple sure. We got 16 times 9. It's 144. Alright. We get plus 144 over 16. I'm going to go ahead and rewrite this up here. Just kind of clean things up a bit. X minus 3 squared is equal to, we have y over negative 16 times, we're going to add these things together, add 3 plus 144, which gives me 147 over 16, positive 16 in this case, positive 16. Okay. Whew. All right. Now what we want to do is we want to get rid of this whole 16 situation. So if my denominator is the negative 16, let's clear that out. Remember, if you're dividing by negative 16, the opposite operation would be to multiply by negative 16. So if I multiply, I'm going to multiply both terms by negative 16. So if I were to distribute, I know that my 16s cancel out, and I'm really just left with negative y minus, that's a positive y. Negative times a negative cancels out. Positive y minus 147. What you do to one side, though, you have to do to the other side. So I had to multiply by 16 here as well. So I'm left with negative 16 times the quantity of x minus 3 squared. And then my last thing is to add 147 to both sides. Add 147 to both sides. This goes away. I get negative 16 times the quantity of x minus 3 squared plus 147 is equal to y. And just for comfort's sake, let's go ahead and write that y in the front, and we get our vertex form. That is our vertex form. So again, this is a tough example, but if you followed through, you should be in good hands. Pause and rewind as needed when you guys take your notes. So let's go ahead. My vertex then is simple. It's just positive 3 and 147. Positive 3 and 147. Alright guys, and that just about wraps it up. So again, please go ahead and write your notes down. You can pause and rewind as needed. Hope you guys learned a thing or two. Alright, see you next time.